In today's session, we will take a look at what is data modeling and what is the relationship and how to define or create the relationship between tables. Previously, you have learned how to connect to various data sets and how to perform the data transformation using Power Query Editor. And today we'll start the new topic. And at the end of it, end of the session, we will spend some time to uh, cover only one topic, right? So the problem with connecting to my Power BI Cloud service. Yesterday I was posing that issue. Today, because it's too early here, I could not shake it up. So why data modeling? So I'm a Power BI developer. Why should I learn data modeling? So unlike Tableau and ClickSense, when it comes to Power BI, you should be good at data modeling, because without creating the data model or solid data model design, you cannot expect an accurate report. Okay, the data will not be accurate. It will not filter the tables. Okay, hence it is necessary that you have to learn the mandate that you should learn the data model. And the interview also, they'll ask you questions around this topic. Okay, in today's session, we'll take a look at what is a data model and why a data model why data model needs to be done, and what is cardinality, and the different types of relationships or the cardinality. We'll take a look at it. And also we'll spend some time in understanding what is data warehousing, what is data lake, star and snowflake schema. If possible, in today's session, we'll cover the active and inactive relationship. Okay, now let us get started with the data model. What is a data model? Data model is like a blueprint. It is something like before you construct a house, you need to have a solid blueprint in place. If you don't have the solid blueprint in place before constructing the house, what will happen? Later point in time, if you have to make some alterations to your house, it'll cost you a lot. Okay. Same way when it comes to data modeling, before you develop any applications or when you launch any website, make sure that you have the solid data model in place. Okay, the data model can be compared to roadmap or an architect's blueprint. It represents the framework of what the relationship are within a database. Okay. So why data model is required? So the data model is very much important because the data exploration will be faster, and aggregations are simpler to build, and the reports will be more accurate, and writing reports takes less time. Okay. And the next thing is we'll take a look at the types of data model. We have three types of data modeling. Okay. Phases, data model phases. In the software development life cycle, if you work in any software project, there is something called software development life cycle, SDLC. Software development life cycle. The typical software development life cycle start with the requirements phase, and then you have something called high level design and the low level design phase. This is one phase, first phase, and second phase, and third phase, and fourth phase is like your coding. Cut phase, we call it cut phase, which means coding and unit testing, coding plus unit testing. And the next one is the QA testing will be there, and UAT, and finally deploying deploying the reports on cloud or something like that. Okay. So in this case, the conceptual data model, we arrive at as part of the requirements phase. And then in high level design, we create the logical data model, and also we come up with the physical data model. So who can do the data model creation? So it is the responsibility of the data architect. Responsible of the data architect, but we cannot expect the customer to onboard or hire a data architect separately and Power BI developer separately, right? So nowadays they expect the Power BI developer should be good with the data modeling, and they cannot afford hiring separate person for separate thing. Okay, so as a data analyst, Power BI developer, you should be knowing data model design. So as part of the data model design, right? So there are three phases. You need to start with the conceptual data model, and then the next one is the logical data model, and the last one is the physical data model. So now we will take a look at the conceptual data model. Conceptual data model is an abstract data model. It is the preliminary step wherein we define what entities the system or database should contain. Okay, let's say in the case of grocery business, it needs to represent its data model. So in that case, for example, right, the customer places an order and products appears on orders, and finally there is a cardinality. It is also called as a relationship. Okay, first we need to identify what all the entities are there as part of the conceptual data model. So by interacting with the various stakeholders in your company, or by involving the key stakeholders across the board within your organization, you conduct a workshop and then you discuss with them what entities are there, what entities are they using it, and what kind of relationship those entities have it. You need to understand that one. Okay, and so in this case, not only understanding the entities that are available is sufficient. Okay, so customer is an entity, and order is an entity, products is an entity, and each of the things are called as an entity. It is also called as a table. Okay, and not only identifying the entities are sufficient, you need to identify the relationship. We need to understand the relationship between the tables. For example, a customer places 0 or more order. How the customer is related with orders? Customer places 0 or more order. What kind of relationship? 0 or more. See, let's say I have 1 M customers. My customer base is 1 million. It doesn't mean all the customers can place an order on a daily basis. There are some customers, all right, they may not buy the product on a daily basis. There are some customers, they may order it on a daily basis. So hence the relationship here is 0 or more. Okay. And the next one is the order. When you take this entity, the order is placed by 1 or more customers. Okay. And the next one is the products appear on 0 or more orders. Like I said, on 1M, though we have 1M customers, not necessarily all the 1M customers should order it on a daily basis, right? There is no necessity. And similarly, in the case of Amazon, another leading e-commerce website, if you see, they listed 1 billion products. Not necessarily all these 1 billion products to be purchased on a daily basis, right? So hence the order, the products may appear on, right? So the products appear on 0 or more orders. There are some products it may not appear on the product at all. Customers are not at all ordering some set of products. Sometimes they order the product, the same product. Okay, so hence the relationship here is 0 or more. Here also the 0 or more. Okay, and the next one is the stores. Okay, but stores definitely, right? So you have, let's say you have, for simplicity sake, you have 3 retail chain. Obviously, there will be some sales, right? So one or many, we cannot say 0 or more, right? So all the stores, the customers, the orders are raised. Okay, 1 to many. The relationship is 1 to many. And categories here also 1 to, here it is kind of, can you say 1 to 1? The categories and products. No, it's 1 to many, right? A single category can have more than one product. So the relationship here is 1 to many. Here is 1 to many, and here 0 or many, 0 or many. So as part of the conceptual data model, at an high level, we understand what are the entities are involved as part of the grocery business, and then what relationship it has in it. Okay, that is what we understand. So now the question is, who is responsible for creating the conceptual data model? Sometimes the business stakeholders or the data architects, if they don't have it, the business analyst, they will be the one working with the data analyst in order to come up with. But in the conceptual data model is done by business analyst usually, to my knowledge. Okay. The next one is the logical data model. It is an extension of the conceptual data model. So the data, the architect or the data analyst, right? So they move, or the business analyst, they move from the big picture of the conceptual data model to the logical data model. So in this case, we start look at the detailed structure of the database, and we add the attributes to each entity. So look here in the customers, what attributes are needed. So customer key, first name, last name, his address, zip code, and his contact number, primary contact number, mailing address, right? All the things. And then in order fact, what all the attributes that are required will be identified as part of the logical data model phase and design phase. And the next one is products. Similarly, in all the entities or the tables, the relevant attributes are identified as part of the logical data model. The business rules such as customer entity have at least one unique identifier. Those kind of things also we'll be able to understand as part of the logical data model. Okay, which one is the primary key? In this case, let's say the customer key is the primary key here. Primary key. And the same customer key is a foreign key here. So why this same customer key is called as a foreign key here? Because in this table, the customer key, the values for the customer key column comes outside of this table. From the customer table, it comes here. See, let's say you have, for simplicity's sake, you have 100 customers. Your customer base is 100, and in this table will have only unique values for each customer. Let's say you have 3 customers by the name of John. 3 customers' name is John. Now you need to, how do you distinguish, whether these 3 guys are same or different using the customer key. There's something called 1, 2, 3. With the customer key, you can identify, oh, this guy is from Delhi, this guy is from Pune, this guy is from Mumbai. Something like that. Okay, with the help of the key column only. But this key column, customer key column, should be unique. In this table, the customer key column will be, this is called your primary key, since this column will have only the unique values in it. Okay, this table is also called as a dimension table. Dimension table. And some people, they call it as a lookup table. When you work with the Americans, right, they use different terms for the same thing. Hence, I just tell the alternative name also. Okay, this is order fact. Look at this as the name, there is a fact table. This kind of fact table. It is also called a transaction table. This transaction table will hold each and every transactions made by the customer. Okay, and the next one is the products. Okay, in the product we have the product key. Okay, these are the the rules. So the how product key and product key. Here we don't have the product key. It should be there here. Product key. Okay, and using the common key column between these 2 tables, we can join this one. So we'll see why we need to join the tables, right? So that we will discuss it little later. At this moment, as part of the logical data model, we start look at the detailed structure of the database by including the attributes, right? So to the tables at the table level. The next one is the physical data model. The physical data model, what we do is we create, we specify the data type. So a customer key is character type. Okay, what is the width? It is something like 15 or something like that. So they specify the data type for each attributes and the width of the attributes, and then they define all the primary key, foreign key, everything as part of the physical data model. The next phase is physical data model. So before we move from one phase to another phase, from conceptual model to data model. So it is what we do is we get sign up from the customers. Once we sign up, okay. So once they say, okay, only this many number of um, entities are involved as part of this business, and if anything else needs to be included in this one, we need to document this one and share it with the customer. Once they wait it by signing it off, then we proceed with logical data model. And once we are done with identifying all the necessary attributes, including the business rules, everything, we need to share this document with the customer side to get their sign off. Once they say yes, because the sign off is an important part. So as part of this, if they find any gap, right, you share this or liaise this document, design document with various stakeholders in your company. So in that case, different people will take a look at it within the department. Even within the department, if they involve different people, they say suggestion, this column is missing, that column is missing, right? So that before they sign off, if they give some feedback, we will make changes accordingly, and then we send it for the final sign off. Once they say yes, go ahead, then we will create the column name, everything. Sorry, the data type, everything will define it. Again, we'll send it for their consent. If they say yes, fine. So we will, this one will be implemented. So the tables, relationship, everything will be created in your database, SQL server or Oracle server, right? We will create it. This is not required. Next one is the data model. Okay, why data modeling is required? Can't I do without data model? Can't I create a report? If you are using a single table, single file, then you don't have to do any data model design. But in the real world scenario, we'll be working with minimum 10 to 15 tables. Okay, if your source system is a RDBMS like SQL Server, Oracle, or Teradata, okay, and if you are using any data file, right? But when it comes to Power BI, irrespective of the type of the file, right? So it will consider everything as a table. We need to create the relationship, no matter what file you use it. End of the day, once you load it, Power BI consider everything as a table. Okay, that is mandatory. But without creating the relationship or data model is nothing but creating the relationship between the tables. If you don't create it, you cannot see the accurate result. It will not do the filtering. It will not do the filtering correctly. So what do you mean by filtering? This is very important. Listen very carefully. Okay, unless the filtering is happening, you cannot do right. So you cannot see the slicing, and you cannot perform slicing and dicing. So these are the two tables, country table, and this is my transaction. This is my lookup table or dimension table. I call it the dimension table, lookup or dimension table. This is my fact table or transaction table. And what is the common column between these two tables? Country ID. So hence we create the relationship between. So once you create the relationship between the table, right, so it will create a link here, something like this. Okay, so there is a relationship, right? So one to many relationship. Okay, but in this table, the country ID is the unique key. Hence, you can see for each country only one ID here. So this ID should not repeat here. You should not have any duplicate values. Remember this. US should not repeat more than once. Whereas here, the same country can be repeated more than once because the transaction file. Okay, this is a lookup file. It's a dimension table or lookup table. The lookup table or dimension table should have the unique key in it, whereas here it is not like that. Now the question is relationship. Why relationship is important. Without relationship, you cannot use this table to filter this table. What do you mean by filtering? Look here, this is my country table. So we have 4 records. Once you create the relationship, what happens behind the scene? Let's say you are creating a report. You're creating matrix report. So, or matrix visual. You're using a matrix visual. So you wanted to, let's say you are dragging and dropping the country name there, country name from this table, and then quantity and sales. For simplicity's sake, you dragged and dropped the quantity from this table to this matrix visual. what will happen is, for each country, right? So by, very well, so by default, each quantitative variable will be, you can see, just next to the quantitative, you can see this sigma sign, which means it does the aggregation automatically. In the case of matrix, when you drag and drop the country name here, so your manager wants the country name. Along with that, he wants to see how many units sold in each country in total. So aggregation. So in this case, what happens when you drag and drop? So, but you need the data from these two tables, because he wants the country name to be displayed along with the quantity. But again, the quantity should be summed. So here what happens, since you have created the relationship based on the common key column between the two tables, you should be able to retrieve the data from the country column and quantity column simultaneously. And other thing is, and it goes to, since you have created the relationship, it goes to the first record, and then it goes and pick up this value, United States. See what all the other, see here I highlighted in red color, right? The other, the US related records. So once it select this value, the first record, the corresponding US related records will get filtered automatically in the case of matrix. And then what it does is it applies a sum. So 2,500 plus 3,500, and this one, right? The total of the United States. So here in the matrix, if you see United States in this country, how many? Okay, so quantity is very simple to add. So 2 plus 1 is 3, 6, 16 plus 8, 24. 24 units sold. And next, it will skip to the next record, and then Australia. It will display the Australia in your matrix. In Australia, automatically the Australia related records will get uh, filtered. So these two records will get filtered automatically. 15 plus 2, 17. The automatic filtering is happening, okay, without even writing any logic or any DAX function. The filter is happening automatically, and also the aggregation is also happening automatically when you use the matrix. You don't have to write any DAX function. It is because of the relationship you created between the tables. If you don't create the relationship between the tables, the filtering will not happen automatically. The United States, what will happen is it will count the total quantity. Let's say total quantity, hypothetically, let's say you have 54 is there. For all this country, it will display 54, 54, 54. If you don't create, if you delete the relationship between the tables, or if you don't create any relationship between the tables, it will not do the filtering correctly. Okay, look here, since you have the relationship here, United States record got picked up, and the corresponding United States records got filtered, and then it applied the sum on your quantity. The next, it moves to your second record, and the corresponding Australia records get filtered, and it applies the sum on this quantity, and it goes till the end of this record in this lookup table. Now we'll take a look at the same in Power BI Desktop. Here in this case, I'm going to load the customer table. So instead of country, customer table, and then the sales table will use it. So this you know already, right? So I don't have to explain. And the next one is I just go here, and the next one is sales fact. Okay, here I have something like NC sales. Okay, done here. And if I do close and apply, I have imported two files. For a better understanding, I just rename this table. I just say rename here sales fact. This is my transaction table. And I just, you can rename the table here also. And I say dim customer dimension. This is a naming convention we use it. We never say customer dimension. We use dim customer, something like that. And then if you go to this model view, you can see that a relationship got created automatically between these two tables. I did not create any relationship. Power BI desktop by default detect the relationship automatically between the tables, and it creates the relationship. So this is what relationship, the line, okay, the link between the two tables. You can see it here. When I hover the cursor on top of this one, you can see on the left side and right side, the cust ID column got highlighted, which means these two tables have a common column by the name of cust ID is available. So with this common column, the relationship got created. And as I said earlier, the customer table, for each customer, a unique customer ID will be there. There will not be any duplicate. Okay, hence it is, you can see the one on this side. Okay, and you can see star here, so many. For a single customer, order more than one product. Okay, hence one to many. The arrow is going down here. Okay, if I keep it something like this, you can collapse it also. You just click on collapse, and you can click on the collapse here also, so that you can refer, especially when you have multiple dimension tables and more than one fact table. If you keep it something like this, it will be easier to refer. This is one way of creating the relationship. Now I just go to the report. Now I just show you the importance of the relationship, creating the relationship between the tables. I just click on the matrix visual. This is called matrix visual. And then we'll discuss about each and every visual in the later section in detail. Don't worry. Look here, I just simply drag and drop quantity column here. If you see on the right side here, the quantity, just next to that, you can see the sigma sign. When you click on this column quantity, on top, you can see that the quantity column name and the data type and the format, whole number, and summation sum. So by default, it does the aggregation. Okay, when you move this column into a, when you drop this column into a visual, by default, it gives you an aggregation. So 2,755 quantities we sold in total, all the customers put together, this many number of units we sold. Okay. So here we have, we can see only one value here. I just drag and drop the customer name. Customer name is a text data type along with this numeric value or numeric column. If I drop this one here, look here, it does the filtering automatically. So earlier we have seen, I just remove the customer name. If you have not noticed, right? So I look here, you remember this 2755. The moment when I drop this here, so out of this total units sold, 2,755, how much units we sold to each customers? It gives the breakup in, the total sum. Chris uh, purchased 1,337 units, and Hemal, he purchased 109 units in total. Okay, that's what. So this filtering is happening automatically. I did not write any DAX functions, nothing. That is the beauty of Power BI. Okay. And now if I go and remove the relationship between these two tables, look here. I hope all of you remember the total units sold, right? This is the value repeated across the rows. It is not doing the filtering. This column comes from which table? Customer dimension table, right? This column comes from customer dimension table. This quantity comes from the sales fact table. If I want this table, the customer name in this table to filter my sales fact table, it should have the relationship. Without relationship, if you delete the relationship or if you don't create the relationship, you will find something. Supposing when you find something like this, but in the real time scenario, you will be you will be having multiple tables, you'll be using multiple tables, close to, let's say, 15 tables, and then you did a lot of transformation and a lot of visuals are there, multiple pages. Look here, you can create more than one pages also here. Look here, you have 10 pages are there somewhere, right? So when you create, so you got you are completely overwhelmed with so many number of tables and so many pages. And what happens is, when you create some visual, you will find something like that. Means there is no relationship exist between these two tables. So we need to create the relationship between these two tables, or the relationship might be existing already, but they would not have created the relationship with proper column name. For example, I just go here and I just expand it. So how do I create the relationship between these two tables? There are two options to create the relationship between the tables. One is I need to drag and drop this column into this table column. Okay. First of all, these two tables should have the common column. Okay. The name of the column need not to be same, but you should be knowing. If it is same, like customer ID, Power BI automatically detect the relationship, and then it will create the relationship between these two automatically. Here, let's say you have customer ID, here something like customer number is there. But as a domain expertise, you know very well the customer number is nothing but customer ID. But how Power BI will know? So in that case, you need to go and it will not create the relationship. It will not detect the relationship automatically. Since the column names are same, it detects the relationship automatically. In that kind of situations, you need to drag and put it on top and drop it on that specific column. Then the relationship will get created. Once the relationship get created, you need to hover the cursor here to make sure that we have created the relationship between these two tables with the correct columns. Okay, I just show you another example. Sometimes because of the delivery pressure, you might tend to make some mistake, like order ID and customer. You just put something like this, mistakenly create the relationship. Okay, and if you go and see here, the relationship is there, but still it is not working. So where the hell the problem is, right? You will break your head. So that's the reason why creating the relationship is not only sufficient. You need to validate whether the relationship which we created is using the proper column name. No, it is not using the proper column name. Okay, what should I do? You just double click on the link. It will open something like this. Here you can edit the relationship. If you see here, product id and customer id in these two table got selected. You can see the gray color, right? With this you can understand these two table got created with a wrong column name. The relationship got created with a wrong column name. So not the product id, it should be customer id. Now you can correct this one. Or the other way of doing is here itself you can delete it and you can drag and drop it properly on this column. There are two ways. This is one way of creating the relationship manually on your own, dragging and dropping. Other thing is you click on the manage relationship. Here you can go here and create the relationship. So here I just, if I click on edit, it will come up here. This is very easier. You can see the sample data here for for the both the tables. You can see the sample data, and you can, with this you can make out. So these two columns are common between these two tables. Select this one, click on it. But here, if you see here, you have something called cross filter direction cardinality. So many to one, because this is the many side. Like it has transaction data in it, whereas this is one side. Why? Because of one side. Look here, many to one. This is many, this is one. Why it is one? Because this is a dimension table. The dimension table is a lookup table. In this case, we have a primary key column. It will not have the duplicate in it. Hence, it is for each customer, you have only one customer ID. There should not be a duplicate of the customer ID. Hence, this is called your one side, but this is many sided. Look here, the C001 occurs more than one time. Right? This guy purchased in Bangalore and Pune also. Okay, but here you can have duplicate, whereas here you're not supposed to have duplicate. That's why it's called many to one relationship. And cross filter direction is single. Okay, this is how you can create the relationship. Supposing, right, you want to click on new, and then you can just to demonstrate how to create the relationship using this. I just came here. You need to click on this drop down, and for example, I do select PIM customer, and here I just select this. Click on customer ID, click OK. This already there is already a relationship between these two columns are available. For demonstration purpose, I came here, okay, to show you how to create the relationship using this, the dialog box. Okay, now you understood some extent the importance of the relationship, and what is one to many, some extent you understood, and how to create the relationship. In order to create the relationship, you need to have the common column between the tables. The common column need not to be having the same column name. Okay, there will be some kind of naming convention can be different. Okay, but if I drop the relationship, it doesn't do the filtering. In order to the filtering, yes. In this case, the customer name column filters your sales fact table. Okay, so automatically it splits it computes the total say units sold for each customer, right? That it gives you the breakdown of the total quantity sold by customer, right? So that is what it gives. Okay, next we will move on with understanding what is data warehousing, data lake, star schema, and Snowflake schema. These are the important topic. Every BI developer, you are a Power BI developer. I'm talking about business intelligence developer. If you join with any service-based company, there's something called BI team, business intelligence practice will be there. So you'll be you'll be joining under their practice. Okay, business and so here the business, and you should be knowing the business intelligence concepts. Power BI is one of the tools that falls under business intelligence. Tableau, ClickSense, and thought works like different reporting tools also falls under business intelligence. Okay, hence it is important to understand business intelligence related concepts. So as part of this, you should be knowing what is data warehousing, what is data lake. So we'll start with understanding what is a data warehousing. So this is what you can see, the data warehouse in this block diagram in the middle one. This is the central repository of well-structured data gathered from diverse sources. In this case, let's say in my company, the Salesforce related customer relationship data is available in our CRM cloud, the Salesforce cloud. Okay. And then the Oracle apps, that they are my customer is Oracle apps, and some other legacy like mainframe related data, and some external data we receiving it from whenever we make any purchase, we receive the codes, everything from our vendors and other files. Okay, so you receive the data from different source systems. Okay, so what you do is there is something called ETL. Before you load this data into a data warehouse, you need to do some kind of transformation. You need to clean the data, and then only you need to load the data here. Now the question is, why should I extract the data from all these different data sources, and why should I load it again? Don't you think it is a redundant thing? This is for analytics purpose. The data warehouse is for analytics. Okay, this is for application specific, all the ERP applications. For example, Oracle projects. So in the Oracle ERP software is something called costing. Like different modules will be there. Those module specific data will get stored here. Okay, and CRM application related data gets stored here. External legacy and other data also getting stored here. And supposing you just think other is something like your OLTP system. This is the one is holding all your e-commerce website. Let's say in your Amazon, you listed out 1 billion products on your website. Whenever the customer orders any item, this data will get stored here. Not only the transaction data, but whenever the let's say your sellers, right, Amazon sellers, whenever they list their products, new products, it will get stored in another table, products table, category table, subcategory table. Okay, likewise in the OLTP, all the the e-commerce related data will get stored here. This is a transactional data. The customer may order the product, or they may cancel the product after some time, or after a week or so, or the same day. They may change the order, they can modify the order. Okay, before checking out they should be allowed to modify the order. Okay, and they can modify, and they can delete the product before checking out. Okay, and they can add new products. Okay, all kind of crub related, sorry, the crub, so right, like create the product, a new product, and read the data from your product table, category table, and update the data, update your shopping cart, and then crud. Okay, and the delete if you think you don't need a space. So all these kind of operations you do it here. So the data is very volatile here. Okay, so the OLTP database will be accessed by millions of users across the globe. Okay, across the globe, millions of customers are accessing it. According to the statistics from Amazon, every 1 hour, not Amazon, Walmart, every 1 hour, 1 million transactions are done by the customers across the globe. Concurrently, 1 million users, accessing this, side by side, right? Simultaneously, multiple customers are accessing your e-commerce website across the globe. Okay, hence the OLTP database is very busy, and it should be pretty faster whenever the customer raises an order, right? It should store the order, and it should allow the user to check out in a fast manner, right? And it should store the values pretty fast. And if they want to do something of analysis, you saw in the Amazon website, you have something called filtering. Let's say I want to buy a t-shirt, and it gives us some filter, right? So you apply the filter. This is my budget. Okay, this is my size, right? All the things you select it, and then you do it, and then it goes and search matching to these filtering criteria, and then it display all that. It's all happening in a matter of seconds. Why? How it is possible? Because the OLTP system is designed in such a way, right? Here, all the tables are normalized, whereas here, all the tables are denormalized most of the time. Here it is normalized. Since these tables are data model design, they have done the data model design based on the normalization rule. Hence, the design has been done, using the normalization rule, and also the system capacity also matters. Obviously, you need to have, large, you have huge RAM capacity and storage, everything. But along with that, the data model design also plays an important role, because of which the current concurrency is possible. Multiple users can access simultaneously to your database without any delay, without any crash. They can do it. Right. So the data model design for the OLTP is different. The data model design for data warehouse is different. Okay. So now coming back to what exactly data warehouse. So in this case, OLTP, we don't have historical data. Okay. If you take e-commerce, right? So maximum, let's say you have 1 year customer data, that is enough. Right. So there are some orders you did not fulfill it to your customer. While tracking it, you will get to know, okay, the customer ordered 10 days back, not like 6 months back, they ordered the product, you have not yet delivered, right? We don't see. So hence, the data retention period is less here. Maybe 1 year or maximum 2 year data only will be there here. And also, it will have only the up-to-date information. For example, a customer made an order, okay, and so immediately after that, he canceled that order. So what will happen is it is not, it will have only it will not have that customer record because it's cancelled. It will simply remove that, because here they don't store huge volume of data. If the volume of the data is very high in your table, it will not cater to your customers to access the database concurrently. It will slow down the performance. Hence, they make sure the volume of the data is less. It's like in a laptop, if you have huge volume of data in it, what will happen? It will literally hang in your C drive, right? Same thing. That's why they don't maintain huge volume of data. And again, it's a transactional data. You will not have the historical data. Whereas in the case of data warehouse, since it is, this has been created with the intention of performing data analytics, they store the historical data. So the data warehouse will have the data from various source systems, not only OLTP, another thing also integrated. The data is integrated, and the data warehouse is integrated and historical data. It captures the historical data. So as soon as the customer enters the order, so that order will be captured here. And when you cancel it, that data also will capture it. Later point in time, if you want to see how many number of orders cancelled by a specific customer the last 1 month, you want to see the pattern. Okay, some customers, they raise the order and then after 2 days they cancel it unnecessarily, right? Due to competition or jealous or something, right? They do something like this, right? And they raise the order, they cancel it. They won't do some kind of analysis unless you have the history captured here. So which customer ordered when, and when did he cancel it? You need to have all the information here. Hence, every transaction data you will get stored here. Hence it is historical. It is non-volatile. So once you store the historical data, what will happen is the size of the data warehouse will become very huge. You will have petabytes volume of data in it, petabytes of volume in it. What is petabyte? 1024 terabyte into 1024 terabyte. This is what petabyte. The volume of data is very high. So on top, if you have to make any changes to your table, or if you delete a record, or if you make a changes, it will take a lot of time, because in the case of RDBMS, update and delete is an expensive operation. It will consume too much of IO. It will read the data from disk. Anything, if you read it from the disk, it will take a lot of time. It will literally slow down your performance. Delete also expensive operation. Okay, now you understood data warehouse integrated, no historical, non-volatile. It will not get changed. Okay, rarely it will undergo some changes, and it is time variant. So you store the data, the time-based data you store it, so that if you want to perform like for like analysis, year on year sales, quarter on quarter sales, month on month sales, week on week sales, you can do it. Once you store the time-based data here, we can do it. So this is what data warehouse is all about. So it is integrated. The data we extract it from various source systems, and then what we do is before load these data into your data warehouse, we transform the data. The ETL stands for extraction, extraction, and the T stands for transformation. The L stands for load. This is one of the questions was asked by my some employer asked my student in the past batch. That's why I'm talking in depth now. So ETL stands for extraction, forget of being honest, the extraction, and T stands for transformation and load. So what is extraction? The extraction is simply pulling the data from your source system, and then you load it into your, this is called your staging area. Staging area, they will ask you this one. So how do you from where do you get the data? You said you created 10 reports. So where do you get the data? What is the source for that? The source is data warehouse. Okay, for the data warehouse, where the data is coming from, the source system, or we have different source systems. We have something like a CRM application like Salesforce. The data we are picking up from Salesforce application from cloud, and the OLTP server, the SQL server is having the our e-commerce related data, and then other data are available in JSON file or Excel file. All these files we will pull it, and then we will store it in the staging. Simply we extract the data, read the data, and store it here. E and L, extract and load it into staging area. EL. Once you extract and load it here, next step is you do the transformation. Look here, this is what the transformation. You merge the tables, more than one file. Sometimes you may have to combine multiple files in a single file or single table. Sometimes you may have to do left join, right join, and then you need to do aggregation, group by, and then you need to load it into your data warehouse tables. And before you load it, yeah, so apart from this, you need to make sure that you don't have any duplicate records. In case of any duplicate, remove it. In case of any missing values, you address it. Okay, any formatting related issues, right? Everything you address it here, and then you load it here. So once you load the data into your pre-processed data in data warehouse, it will have historical data in it, and the data are clean. And then the reporting users, like let's say you are a Power BI developer, you just connect to the SQL Server data warehouse, and then you simply query the data, and then you populate your visuals, the charts and everything, map, chart, everything. Hope you understood what is data warehouse. Data warehouse source is in historical data. They'll ask you what is the and how many years of data they store in the data warehouse. You can tell them 5 years. 5 years data they store it. And what is the size of this one? It comes close to 2.5 petabyte, but I don't remember it on top of my head. You just tell them approximately 2.5 petabyte volume of data is there, 5 years of data is there. And we have close to 14 dimension tables, and we have two fact tables for the subject area where I work. See, a data warehouse can have multiple subject areas. What do you mean by subject areas? Modules like so the modules are like supply chain. This is one subject area, supply chain analytics. And then you have something else called marketing. Marketing, you have another data, another schema. Okay, these are called schema. And we call the subject areas, SCA, subject areas. Each subject area will have the set of dimension tables and fact table. Here also you have dimension table and fact table, all the things you will be having. And we have something called finance. Finance, you have separate subject area. Even for finance, you have set of dimension tables and some fact tables. There are some dimension tables that can be used across all these dimensions. For example, date dimension. Okay, those kind of things. Fine, you got it. So these are things. So you can tell them that you worked in a sales thing. Okay, you can say in the sales subject area you worked on it. You can say that way. Okay. Now you understood what is data warehouse and the purpose of data warehouse. This is for analytics. You'll have historical data in it, importantly. Okay, it is non-volatile. It will not undergo frequent changes. Rarely it will undergo changes. It will have the data from all the source system and then we store it and then the time it is. See, not necessarily integrated in the sense multiple sources. For example, here you have the OLTP database. This is your e-commerce table, right? So here you have the customer table and then you have something called product. Whenever the customer sign up to Amazon website, their detail will be stored, right? Whenever a new customer data comes in here, whenever a new customer onboards here, that specific customer data should get loaded here, right? And before loading it here, it will be simply loaded here. Now you might be asking this one, we are extracting the customer and any new product comes in, we are loading it here. Simply we are reading it here and then loading it here and then only we are doing the transformation. Why can't we do the transformation while extracting the data? As I told you, this OLTP data is pretty critical, right? So already millions of users are accessing your website. It's already very busy. Since many users are hitting your database, it's very busy to cater to their request. On top, while extracting the data, if you join the tables, what will happen is it will put additional burden on this database. They don't want that to happen. Hence, simply extract the data and load it into staging. This is what you need to tell it to your employer at the time of interview. Simply we extract the data and then load the data to staging. And in the staging area, we do all kind of data cleaning, data pre-processing, everything. Because this is a temporary area. Okay, and here maybe 6 months data only will be there in the staging area because they don't keep huge volume of data. This is just a temporary purpose. And then they send the clean data, load the L between staging and data is L, and between here is EL, and only T is happening in the staging area. Data pre-processing is happening here. You need to remember this. Okay, they will ask you how did you extract these things. So we have some jobs, or you can simply say the data are loaded from the OLTP database to staging using some automated jobs. We don't have any control over here because of security reasons and other reasons. They did not give any access to the source system database. This is the reality. Okay, most of the projects they never give access to the source system database. Simply they have some scripts, automated scripts that will load the data whatever we needed in the common place called ETL, sorry, the staging area. And then from here, what are the tables that we needed, we'll go and pick up and we combine those tables. Sometimes we clean the table, everything, and then we load it into this one. So here we don't have any job. Okay, you can tell them from source to staging, we don't do anything. OLTP to here, and the data is already available in the file or in the form of CSV file. You can say that way. So they give the file in the form of CSV file in a folder, and then we take these CSV files and again we do some of joining everything, and then we do data transfer and everything, and then we will store it in this table, the staging area table, and then we load it here. Okay. So this is little bit confusing for you, but still, if you can understand clearly, you can handle the interview questions. Okay, and between the staging and warehouse, you need to, they'll ask you which table, which tool that you use to perform data. You can tell them we have used Power Query Editor. Okay, Power Query Editor, and also we have used between the data warehouse and for report, right, to connect to the SQL Server, and for the fact table we have used direct query mode, and for some dimension tables we have used import mode to connect to that. Anyhow, we'll discuss this in detail later point in time. I don't want you dump so many things in a single session. You got a better, high level understanding about this one. Hope, right now. Okay, we will take a look at data lake. We have something else called data lake. This term is very popular. And if you look for job description, they'll ask you Power BI and SSIS, SSAS. There are some job description. You can see the ADF, Azure Data Factory, and Power BI, SQL Server, and Cloud, Azure Cloud, and the data lake. You should work in data lake. Okay, all these things you should be knowing it. And we have something called Snowflake. Now Snowflake is gaining a lot of popularity. Snowflake. They'll be asking the combination of these skill sets. They are looking for multiple skill set because they want to be smart. They don't want to hire multiple person. Okay, each and everything they don't want to hire. If a single person knows multiple thing, then so he is the best fit for me. Okay, that's what. So in a sense, you should be knowing data lake. Data lake. In the data lake, we store, even the data lake is some kind of your staging. Okay. In the case of data lake, all the raw data will get stored here. It is also centralized repository. Data lake is also centralized repository like the data warehouse. Data warehouse is also centralized repository to hold the historical data. Data lake is also centralized repository, but it allows you to store all your structured, unstructured data at any scale. Okay, what do you mean by unstructured data? Like text data and images, those kind of things, even including videos and all. See, in the case of Walmart and other companies, so we take some videos of our store and the images, product images, everything we store it. Okay, and so those things, right? We will store it in the data lake. All the data. Okay, you can store your the unstructured data and structured data here, but whereas the data warehouse will have only the structured data because structured, it is sitting on top of your RDBMS database. Anything related to database, it is your structured data. But data lake is a mix of everything, structured and unstructured. So we store the data as it is. For example, the OLTP, as I told you earlier, right? So we store the data as it is here. Simply pull the data and store it here. Okay, it's in simple terms, the ETL jobs, right? It'll go and pick up the data. It'll read the data from customer table or product table, and it comes and spit it here. That's it. The next step is those people, they want the specific data. They can come to this place because centralized repository for the data. Okay. So you come and pick up the data. And then in the case of analytics, you store this kind of your centralized store for your source system data. And then what you do is, instead of this one, right, it's all data lake. All the data are available in the data lake. And from here you pick up and then you do the data transformation, everything, and then load the data into your data warehouse. For your staging area, the source is data lake. Okay, but still you have because it's an RDBMS, you want to do some kind of joining everything. To perform joining operation, if you use the SQL queries, it will be pretty simple and very efficient, right? That's why we have used the database for the staging area. And for the staging area, the source is data lake. You can see that way also. It depends on the customer, okay? And the next one is you do the all cleaning everything and then load it into store. That's what. That's all about the data lake, okay? So this is the difference between these two. So it's a relational database. It's a NoSQL database and SQL, Spark, right? These are your data lakes. And the schema on write. This is only for read purpose. You can read the data here and load it here, write it here. This is structured. It's a combination of everything. This is for reporting purpose, analytics. This is for data science, machine learning, streaming process, all the things, advanced analytics, they use it. The next one is the type of data model design. Instead of saying data model design, when it comes to data warehouse, we do dimensional data modeling. Dimensional data model design. Okay, dimensional data model design. There are two types of dimensional data model design. One is the star schema and other one is Snowflake schema. Why it is called star schema? It is pretty simple. So you can see here in the middle. So we have a lot of tables here. In the middle, we can see the fact table. This fact table is surrounded by various dimension tables. Hence, it looks like a star. So that they call it a star schema. See the fact tables, in this case, we have only one fact table. There are some subject areas you will have two fact tables. Fact compared to dimension table, the fact tables are very less. You will not have many fact tables, but this will have huge volume of data in it. Okay, so when the fact table is surrounded by dimensions, right? So that is called your star schema. So these dimension tables explain the facts in your fact table. Okay, so what does this sales fact is all about? What does it comprises? It has the combination of key columns, the combination of key columns from all the dimension tables. Plus fact. What is fact? Sales amount and units sold and profit, net margin. These are all the facts. Numeric value. It is also called as a measure. Okay, so it is a combination of key columns from all these dimension tables. Suppose you have a product key here, category key, employee key, region key, and date key. All these dimensions key columns should be there in your fact table. So why? Only then you can join the key columns. Only then you can join the fact table with the dimension tables using the key columns in order to get the descriptive information from this table, from the dimension table. Okay, now the question is what value? So it will have the primary key column. Okay, each dimension table will have the primary key column here. Along with that, it will have descriptive information. What is descriptive information? For example, here you have something called product key, product name, and then cost price, and then the effective start date and effective end date. Start date and effective end date. So likewise, all the information gets stored here. Product related information. What is the effective start and end date? The price will vary for the same product in a different time period, right? So for that, they maintain something like effective start and end date here. The product key, product name, everything. So in the fact table, you store only the product key here. Fact table, you have only the product key here. Product key or the key columns, the category key, an employee key, date key, region key. Supposing you want to create a report which should show the sales breakdown by product. So in that case, you need to know the product name, right? To get the product name, you need to have the product key stored in this fact table to join with this table. So because this table is the one holding the product name. To get the appropriate, the relevant product name, you need to join these two tables using the key column. Without the key column, how can you join this? Only when you join this, you can do a lookup and then you can retrieve the product name. So hence, okay, I just give you a simple example. Let's say in your fact table, in quantity column, you have something called 10. Okay, 20 is there. And then here you have something called product ID. Product ID is P01DX-01. This is K02, P75, something like that. This is the product ID. If somebody is asking you how much quantity we sold today morning, all right, can you tell me the product name? Right? If you say POIDX010 and D75K020, will you be able to understand this is just a product key? You want to know the product name, but only the product keys are available here. When you join this product key with this product dimension, you can do a lookup and you can get the product name for the corresponding product keys here. The product name is stored here. Because we cannot store all these tables data in a single table. Okay, it will cause some kind of performance issues, and too much of redundant data will be there. That's why logically they keep region related data separately, product related data separately, and you have something else called dim subcategory separately, and category separately, employee separately. But this one will have the descriptive information about your fact. In this case, the fact is in listening units sold 10, 20. To want the descriptive information, hey, what is this 10 and 20? Tell me this. If you say just 10 and 20, I will not be able to answer. This is, the 10 and 20 we sold in region, South region, on which month? In month September, we sold 10 products in South region, and this is the product name. The product name is something like some product name. Okay, so this product, so and so product, we sold it in the South region on month last week, and this product falls under this category, and this product was sold by so and so person. So with the help of the dimension table, we can describe the fact. Hence, we call the dimension table, we say the dimension table is holding the descriptive information, the product name, category, everything. Okay. So now you understood what is star schema is all about. Okay. What is fact table? What is the dimension table? Now we understood. Next, we will take a look at the snowflake schema. In the case of snowflake schema, the tables are normalized. Some dimension tables are normalized. Usually only in the OLTP database, the tables are normalized. But in some cases, the dimension table also get normalized. Instead of storing all these three tables information in a single table, to save some space, to save the space, they divide the table into three different tables, single table into three different tables. But this is not the right approach, snowflake schema, because it involves joining multiple tables. If you store all the dimension tables, because these are all relevant, right? So product categories, those are relevant. We store in a single product dimension table all this information. We don't have to join this. For example, if somebody is asking you in category, technology category, how much sales we sold in all the regions, can you give me the sales breakdown by technology, by all the regions? In that case, the category and fact table does not have the direct link. Okay, this one has a link with this link, and this one got relationship with this. A product table has a relationship. It's something like if I wanted to know category wise how much sales we made, then you have to join these three tables, and then only you should be able to answer to my query. Joining is an expensive operation. Okay, and need not to nowadays, right? We need less to say about the volume of the data that we are getting it. So 1 billion product, you have a lot of categories and subcategories. Okay, you need to join all these things to, okay, here you have 1 billion products are there. Okay, the category maybe you just sell it under 1,000 category. 1,000 is just less, very less value. Fine, but subcategory, all thing 10,000 subcategories. This is also fine, but to tell my manager, So 10,000 category is how much, you need to join with this petabyte volume of table, right? It's painful thing. Instead, if you have it, everything in a single table, but this is even Microsoft recommends the star schema model. But in the interview, they'll ask you, what is the difference between star schema and Snowflake schema? In the case of Snowflake schema, the dimension tables, gets denormalized. The dimension tables are denormalized. So why it is general? Can you give an example? Gives the same example: category, product, and subcategory. You have separate table for product dimension, subcategory, and these things. Okay, this is the difference between these two. Nothing much. Okay, now review questions. Two types of tables in a star schema. What are those? Can someone type it in the chat window quickly? It's already 10:20. Yes, we'll spend some more time. Two types of tables are there in star schema. We just discussed about the star schema, right? What the two types of tables are there here at a high level? Satya, very good. So dimension table and fact table, right? Dimension table, and in the star schema, we have dimension fact tables are there. What is the difference between fact table and a dimension table? Fact table store observations or events, while dimension tables contain about specific entities within the data. Okay, you can frame your own definition. Okay, and the next one is the types of relationship. What are the types of relationships are there? Just give me 2 minutes break. Let me grab some water. I'm feeling thirsty.